Hi everyone, welcome back to Life Technologies YouTube channel and thank you for watching. So this is a continuation of our Huawei Lab simulation series, and in this episode we'll be discussing how to implement INDIAS BGP MPLS IP VPN option A on Huawei routing devices. So we've mentioned that service provider networks normally span multiple autonomous systems, and we have different regions, or the network will be segmented into different regions or different clusters, and then each region or cluster will be configured with a different autonomous system. So we can have maybe 6 or 7 or 8, because remember, service provider network could be all over the country. So we need to be able to segment the network into different autonomous systems for ease of management and control of routing information. So once we have segmented the network into different autonomous systems, we need to be able to ensure that we have communication between these autonomous systems. And many times we have different customers connecting to multiple autonomous systems. So you can have a customer in one region, maybe it could be the branch office connected to the local autonomous system, and then we have another branch that is connecting to a different autonomous system. So the service provider network should be able to ensure there is communication between these branches. We need to have communication over our service provider network. So that's why we'll be discussing how to implement the INDIAS BGP MPLS IP VPN options on this episode. So we have different options. The INDIAS BGP MPLS IP VPN has 3 options. We have option A, option B, and option C. So in this lab, we'll just be focusing on how to implement option A. And this is the topology that we'll be using. You can see that we have the service provider network spans 2 autonomous systems. We have AS100 and we have AS200. And then we have customers connecting to AS200, and we have branches of the same customers connecting to AS100. So in AS100, we have 3 routers. We have the ASBR, the PE, and the PE. The ASBR is the autonomous system border router or the boundary router, whichever you choose. So the SBRs of the 2 autonomous systems are connected, and that's where we need to find a way to ensure that we have communication between these autonomous systems. So they are the border, they are the boundaries of the 2 autonomous systems. So for this implementation, we need to configure some protocols. We need to ensure that we have reachability within the autonomous system. That's why we are configuring different IGP protocols within the autonomous system. So for AS200, we are using ASIS, and then for AS100, we are configuring OSPF as our IGP. So once you've segmented your network into different autonomous systems, you can go ahead and implement different IGP protocols within the autonomous system. You can use EBGP, you can use OSPF, ISIS, RIP, whichever protocol you choose or whichever protocol is supported by your vendor. So we have customers connecting to AS200, we have customer 1 and customer 2, and then we have customer 2 and customer 4, they are connecting to AS100. So the objective of this lab is to ensure that we have communication between customers within the same VRF. So we have VRF1 and VRF2. Customer 1 and customer 2 belong to the same VRF, that is VRF1. And then we have customer 3 and customer 4 who belongs to VRF2. So at the end of the lab, we need to test the reachability between customer 1 and customer 2 and customer 3 and customer 4. And remember, with the VRF implementation, we can not have communication between customer 1 and customer 3 because they are in different VRFs unless we make some configuration changes. So we'll be configuring OSPF, ISIS, BGP, MPLS, and then LDP. So OSPF and ISIS, those are the IGPs. and just to ensure that we have connectivity or reachability between different nodes. And then we need to implement BGP. So for BGP, we need to configure BGP peering session between different nodes. We'll be configuring BGP VPN before peering between P1 and SBR1. And then we also need to configure BGP VPN before peering between SBR2 and P2. Once we have configured the peering session between the PE and SBR, we now configure SBR to SBR BGP peering session between the two nodes. And then within the autonomous system, we also need to ensure that we have MPLS and LDP. So remember, we are using labels, so we need LDP for the label distribution. And for the customers, you can see that they are also assigned different autonomous systems. So we'll be using BGP as our PECE routing protocol. So we'll be configuring BGP peering sessions between the PEs and the customers. So before we start our lab simulation, we need to have a basic understanding of this option A. I've mentioned that we have option A, option B, and option C. So we need to understand some basic features of option A. So option A, many times we refer to it as back-to-back VRF or VRF to VRF peering. So instead of running MPLS between the SBRs, we are just using normal IP routing between the SBRs. So we don't configure MPLS or MPLS LDP between the SBRs. We are just using the normal IP routing between the SBRs. And given that we are not configuring MPLS, so the SBRs will take the peer SBR as its CE. So SBR1 will see SBR2 as just a CE. And then SBR2 will see the peer SBR also as a CE, the customer edge router. And the SBRs will be advertising the IPv4 routes to the peer SBR through EBGP. So we are configuring EBGP sessions between SBR, and they will be just exchanging the normal IPv4 routes. Remember, we are not configuring MPLS between the SBRs, so we'll just be using the normal IP routing. No labels assigned for the traffic exchange between SBR1 and SBR2. So another thing that I need to mention is SBR routers keep all the VRF route for customers who require inter-AS services, hence high memory usage. So if you have many customers, if you have, for example, 100 customers, or you need to configure many VPN peering between the SBRs, we will have high memory usage on these SBRs because they need to keep all the routes, all the VRF routes that are being learned from the customers. So this one makes it a requirement that these SBRs should be high-end devices. You cannot use low-end devices as SBR. They may not be able to handle the huge number of routes from the customers. So the biggest disadvantage of option A is that it has poor scalability. Remember, we've mentioned that the SBR have to manage all the VPN routes, and we need to create all these VPN instances on the SBRs for each customer or for each VPN. So this one makes it not scalable enough. If you have, for example, 100 customers, it means you need to do manual configuration of 100 VRFs on the SBRs. And we are also consuming resources on each SBR to process the routes for every customer. So this is not scalable enough, and that's why many times it's not preferred for service provider network that has many customers. And then for the SBR to SBR peering, many times we need either to have a physical interconnect for every VRF, or we can use subinterfaces. So we end up requiring to have many subinterfaces, or if you are not using subinterfaces, you need to have the physical connections between these routers. So if you have 100 customers, you need to create 100 VPNs. It means you need to have 100 physical interfaces, which is not applicable. So it has poor scalability. But the biggest advantage of option A is that it's very easy to implement, it's very easy to configure and troubleshoot. And this is mainly preferred when the number of inter-AS VPNs is small. So if you have maybe 4 or 5 VPNs or even 10, you can go with the option A, because it's very easy to configure, it's very easy to troubleshoot compared to the other options. So in our subsequent episodes, we'll also be covering option B and option C. So another thing I need to mention that if you are not familiar with service provider networks, remember we have another series for IP RAN technology where we are discussing how to implement IP RAN technology for service providers. So you can check out on our channel and have a look at it to give you a better understanding of service provider networks. So we need to start doing our lab implementation. And this one we'll be doing step by step. We'll be configuring all the routers and troubleshooting step by step, just so that we have a good understanding of how to implement this option A. So the first step that we need to do is to configure names, the system name and interface IP addresses in S200. So with the topology setup, you can see that in S200 we have 3 routers. We have P1 that is connecting to the 2 CEs, customer 1 and customer 3. And then we have P, the provider router. So for the provider router, we don't do any BGP configuration. We'll just be configuring MPLS and IGP, because for it will be doing the label swap. And then we have the ASBR connecting to the other end SBR. So this is the topology that we are using, just as a quick reminder. So the first step, I mentioned that we need to configure system name and interface IP addresses in S200. So I will start by configuring PE01, the provider edge router. So we need to configure the system name, and then we create loopback 0. This loopback 0 will be used for establishing BGP peering session, and it can also be used at the network entity when we are implementing IGP in our AS. So the first step is to configure P1. So I need to P1, I will undo terminal monitor. Then I can clear the screen. So this is P1. We have configured the system name to P01, and then we configure the loopback interface and configure the physical interface connecting P1 and P1. So on P1, this is the next router that we need to configure. I will undo terminal monitor. Then I need to clear. So on P1, we do the same. We configure the sysname to P01, and then we configure the loopback interface with the loopback IP. And then we have the 2 interconnecting interfaces to P1 and SBR1. So on this router, we'll do the configurations. So I can run the command display IP interface brief, and we can see that we have assigned these 2 IP addresses on this interface. On P1, we can also do the same, display IP interface brief. So we have this interface, it's up, the protocol and the physical status is up, and we also have the loopback interface, which is also up physically, and the protocol is also up. So we also need to configure SBR. Remember, this one we are just configuring the interfaces within our MPLS backbone. We are not configuring any interface going outside the MPLS backbone. So on this SBR, we will undo terminal monitor again, then just clear the screen so that it's clear. So we can configure the interface IPs, display IP interface brief is the command that we'll use to be able to see the interface IP configured on this router. So we have a gig 00, and then we have loopback 0 with 4.4.4/32. So once we have configured the interface IPs, we need to move to the next step. Remember, I've mentioned that we need connectivity between these nodes. So our next stage will be to configure IGP, and in this case, in S200, we are using ASIS as our IGP. And you can use any other protocol. You can choose to use OSPF, you can choose to use RIP, or any other protocol that you prefer. So on P01, we'll be configuring ISIS process 20. And for this ISIS configuration, we need to specify the ISIS level. Remember, ISIS supports 3 levels. We have level 1, level 2, and level 1.2. So many times on the service provider network, we choose to go with the level 2 so that all routers are part of the backbone. So they will be able to exchange the link state information without any challenge. So we'll be configuring all routers with level 2. And then we configure the cost style. For the cost style, you can choose to either go with narrow or wide. Narrow is limited from 0 to 63, but if you want to use higher values, you can go with the wide one. And then we need to configure the network entity. So with the network entity, we are deriving the system ID from the loopback IP. So that's why you can see that this is configured as the system ID, which is derived from the loopback IP of P01. So these are the configuration that we need to configure for ISIS. And then we also need to configure the IS name, just so that it's very easy to identify the peering session between the two routers. And once we have configured the ISIS protocol, we also need to enable it on the interface. So to enable it on the interface, it's very easy. You just need to run this command, ISIS enable, and then you specify the process ID. So we are configuring on loopback 0, and we also enable it on the physical interface connecting the two routers. You can specify the circuit type to be point-to-point. This is normally the one that we go with for service provider networks. And then you can also configure the cost. If you have multiple links and you need to control the traffic flow, sometimes you can go ahead and implement the manual cost. You configure the cost on the interfaces. So we'll configure P1. P1, we need to configure ISIS. So I will run these commands. So if I display ISIS interface, we expect to have two interfaces. We have loopback 0. And then we also have the G001 enabled with ISIS. So the next step is to configure the next router, that is P01. So for P01, remember we have two interfaces, two physical connection between SBR and the PE01. So we also need to enable ISIS on those interfaces. So we are creating ISIS process 20. I've mentioned that we are using level 2. And then cost style, we set it to wide. And then network entity, we derive it from loopback 0, and we give it the IS name of P01. So these are the configuration that we need to put on P01. So we are enabling the ISIS on 3 interfaces. So on P01, we can display ISIS interface. So we have the ISIS interface, 3 interfaces, the interconnect between the two routers, and also the loopback interface. So the last part of this step is to configure our SBR1. So on SBR1, we are also configuring the same ISIS process, IS level, the network entity derived from loopback 0 or 4.4.4.4, and then we give it the IS name of SBR1. And we enable the ISIS process on the interfaces. So I will configure SBR1. So I can display ISIS interface. We have these 2 interfaces enabled with ISIS. I can now run the display ISIS peer, And you can see that we have a peering session to P01. The peering session is up between the two routers. On our P1 display ASIS peer, we have two peering sessions to P01 and SBR1. So our peering sessions are up, our IGP is running okay. We can display ASIS route. You can see that we are getting the routes from the peer. We can display ASIS interface verbose, and we will have more details about the configurations, the timers, the hello timers, and many other details about our ASIS protocol that we have configured. On P1, we can also display ASIS peer. So we have a peering session to P01. You can see that the IS name that we have configured is the one that is indicated on system ID. Display ASIS routes. We have the routes. You can check the LSDB, display ASIS LSDB. You will have the LSPs in this LSDB. So we only have the level 2, because remember all our routers have been configured in level 2. So you can display IP routing table. We are learning ASIS routes from the peer devices. So we are able to ping 4.4.4, which is the SBR1 loopback IP, and we can be able to ping the 3.3.3, the loopback IP of P router. So this one confirms that our protocol is running okay. So we can move to our next stage of configuration. So the next stage of configuration is to configure MPLS and MPLS LDP on all routers in S200 and enable it on the interface. So for MPLS, remember we are configuring MPLS VPN. So we need to have MPLS running on this network, and we also need MPLS LDP to be able to distribute the label. So we are using the label distribution protocol as our signaling protocol. So for MPLS configuration, first stage is we need to configure the LSR ID. So you cannot enable MPLS before you configure the LSR ID. If I try to configure MPLS on this router, you can see that we need to configure the MPLS LSR ID first. Once we have configured the LSR ID, we can now go ahead and configure MPLS and also enable MPLS on the interfaces. So we'll be using the loopback IP as our LSR ID, and then we can now enable MPLS and enable MPLS LDP. Once we have enabled these two, we can now go ahead and enable MPLS and MPLS LDP on the interfaces. So these are the configurations for P1. And remember, we only enable on the interfaces that are in the MPLS backbone. So on P1, I can now configure the LSR ID and enable MPLS on the interface facing P01. The next stage is to configure P01. So on P01, we have two interfaces in our MPLS backbone. So we need to enable MPLS and MPLS LDP on both interfaces. And if you miss on one interface, the service will not flow through. So we need to always enable MPLS on all the interfaces in our MPLS backbone for the traffic to be able to flow through our service provider network. So on P01, we'll configure the two interfaces, enable MPLS on them. So I've done that. The next stage is to configure SBR1. So on SBR1, we also configure the MPLS LSR ID at the loopback IP, enable MPLS, MPLS LDP, and then these are the interface configurations. So on SBR, we configure. So with this, we can check our LDP status. We can do MPLS LDP session. You see that we have a peering session from P1 to the P router. When we check on this router, we expect to have two MPLS session, MPLS LDP session. So we have two LDP sessions, two MPLS LDP sessions between P01 and PE1, and also P01 and SBR1. So we can display MPLS. Let's see which other commands we have. MPLS interface, we have two interfaces already enabled with MPLS and MPLS LDP. We can display MPLS LDP. We can check the LSPs. So we have the labels are assigned to different IP addresses. You can see we have the in and outer label, and then we have the next hop and the interface. So this one confirms that our MPLS and LDP is working okay on the in AS200. So the next step of our configuration is to now configure BGP peering sessions between P01 and SBR01 in AS200. So remember, at the end of the day, we need to ensure that these two routers are able to exchange VPN routes between them. So that's why we need to configure BGP peering session between them, and we'll be configuring the BGP VPN v4 peering session. So for BGP VPN v4 peering session, first, we are configuring in AS200, so we need to run the command BGP and then the AS number 200, and then we configure the peering session. So we have peer 4.4.4, they are in the same AS, so it's AS200, and we are using loopback interface as the connect interface for all the iBGP sessions between different routers. Then we need to enable it within the VPN v4 family. So these are the configurations that we need to run on P01. So on P01 we can configure BGP. Quit. We can display this just to verify that our configurations are okay. Then we can move ahead and configure our SBR1. So on SBR1, we do the same. They are in the same autonomous system, so it's BGP 200, and then we configure the peering session between SBR1 and PE01. So these are the configurations that we need to run. So on SBR1, we can configure our BGP peering sessions. You can also configure the router ID, so we can configure the loopback IP at the router ID for this case. And then on P1, we can also do the same. So we can configure the router ID 4.4.4. So we can check the BGP peering session between them, display BGP VPN v4, all peering. It's still idle, not established. It will take some time before it's established. So you can check some different stages of BGP peering session states. So it's still idle. It will take some time. It needs to take some counters before it tries to establish the BGP session. You can see it's now in open send, and now finally it's established. So we have our peering session in established state, which means it's fully up, and they are exchanging different messages. You can see we have the AS, it's 200, message send, message received, message sent, version, it's version 4. So on SBR, we can also verify that our peering session is up. Display BGP VPN v4 all peer. So our peering session with P01 is up. But if you display BGP VPN v4 all routing table, we don't have any route. Remember, BGP doesn't discover routes. We have to inject routes to BGP for it to be able to have routes. So our BGP peering session is up between the PE and the SBR. So the next stage of configuration is now to configure routers in S100, and we'll be following the same stages. We need to configure the interfaces, we need to configure IGP protocol, and then we can configure BGP peering session between the SBR and the PE router. So I will go ahead and configure SBR2. So for SBR2, we have two interfaces. I will undo terminal monitor again. So we need to configure the sysname and configure the loopback IP and the interconnect IP that is in the MPLS backbone. So once we've done that, we can go ahead and configure our P02. So for P02, we have two interfaces in MPLS backbone. If you've missed the topology, so for P02, we have two interfaces, system. So I can quit. And then we need to configure PE2. So for PE2, we only have one interface in the MPLS backbone, but we also need to configure the loopback IP. So these are the configuration that we need on P02. So on P02, I will undo terminal monitor. Then we can configure the interface IPs. So the next stage is now to configure OSPF. Remember, we are using OSPF as our IGP. So we need to configure OSPF on these routers, and we are using loopback 0 as our router ID. So on P02, we need to configure OSPF as shown, and then we advertise the networks in the MPLS backbone. So we'll be advertising the network of loopback 0 and the network of the connected interface. So on P2, we'll start with P2, paste, display this to verify the configurations, and then we'll wait until we have configured all the routers for our peering session to come up. So I'll configure P02. P02, we are advertising the loopback IP and also the interconnected interface to SBR2 and P2. And once we configure, we expect our OSPF session to come up between P02 and P2. So you can see that we have a peering session that is now up, and you can see the states, the state changes. We have exstart, we have exchange, we have loading. So these are just stages, and when you are configuring, it's very easy to see that this is the transition from one stage to another. We have down, we have init, and then where is the other stage? We have two-way, we have exstart, we have exchange, and then we have loading. So these are just stages, and you can clearly see them when you are doing the configurations and doing the lab simulation. So this is one interesting part of doing labs. You get to see what you have learned in the theory part. So the next step is now to configure our SBR. On SBR, we are configuring the router ID to be the loopback IP, and then we are advertising the two networks. So this is on SBR2. So on SBR2, we need to configure OSPF, and we expect the OSPF peering session between SBR2 and P02 to come up also. But given that I've disabled a terminal monitor, so we need to check it on P, and you can see that the peering session has come up. So we can verify that we have display OSPF peer. We have two peering sessions, and these are the details with the DR, with the BDR, the IP addresses that have been used, the timers. You can see all those details. You can display OSPF interface. We have these interfaces in OSPF. On SBR2, we can also display the same, display OSPF peer. We have peering session, display OSPF LSDP, so that you are able to see the LSs. So we have LSA, we have the router and the network LSA on this router. On P2, we can also display OSPF LSDP. You can see that we have the different type of LSAs. We can display OSPF interface. Remember, on this router we have enabled 3 interfaces, so we have the 3 interfaces: the state, the DR, the BDR, and the cost, the priority with the DR, with the BDR, and even the network type. Remember, we have not changed the network type, and if you don't change it, by default it will be broadcast. So that's why we have the network type of broadcast on this router. So we have verified that our OSPF is up. On SBR2, we can verify that we can ping. On P2, let me see, display IP interface brief, just confirm the IP address of loopback 0. Display IP interface brief. We have the IP of 7.7, so on SBR we should be able to ping 7.7.7. We are able to ping. So the next step is now to enable MPLS. For MPLS, I'll be doing the configuration. Remember, I've mentioned that we need to first configure the LSR ID. So the LSR ID, we are using the loopback IP. So from here, you can see the loopback IP is 5566 and 77. So the first step on SBR1, I will configure the MPLS LSR ID, which is 5.5.5. Then I need to enable MPLS and enable MPLS LDP. So we have enabled the two. Now we can configure the interface. We need to see the interface connecting these two. So it is gig 001. So for interface gig 001, we need to enable MPLS and MPLS LDP. So once we have enabled MPLS and MPLS LDP, we can move to the P router. We need to verify the loopback IP, display IP interface brief. The loopback IP is 6.6.6. So I will configure the MPLS LSR ID to 6.6.6. I enable MPLS, enable MPLS LDP. Then quit. Now we can go ahead and configure MPLS on the interfaces. So we have gig 00 and gig 001. So interface gig 0/0/0, enable MPLS, enable MPLS LDP. We need also to enable it on gig 001. We'll enable MPLS, MPLS LDP also. So we have enabled MPLS and MPLS LDP on the interfaces. We go to P2. We need to configure the LSR ID of 7.7.7, enable MPLS, and enable MPLS LDP. Then we need to verify the interface connecting the two. So we have gig 00. We'll do interface gig 00. We enable MPLS and then MPLS LDP. So we have enabled our MPLS on the interfaces within the MPLS backbone. So we can display MPLS LDP session. You see that we have a session up on our provider router. We also need to have a session up, so I can do display MPLS LDP session. We have two sessions. They are all operational. We can display MPLS LDP LSP. We have labels assigned, the null or different labels assigned for different prefixes. So we have configured MPLS and MPLS LDP on our all routers in S100. The next step is now to configure BGP peering session between P02 and SBR. So the same way you have configured peering session between P1 and SBR1, we also need to enable BGP between these routers, the VPN V4 peering between the routers. So I will configure SBR2. For SBR2, I'll run these and quit so we can display these. We can configure the router. I think this is not the right IP. This one should be the configuration for P2, not SBR2. No, it's okay. We are peering to the loopback IP of P2 is 7.7.7, so this is okay. We can configure the route ID to be 5.5.5 and display this again. So we have the BGP peerings configured. We need to configure P2. So for P2, I'll pick the configuration. We are peering to 5.5.5. So these are the configuration that we need. I'll go to P2 and run it. Then return. I'll save the config. Yes. Can overwrite. Display BGP VPN V4 all peer. So it's still in idle state. It has to transition into different BGP states. Once the time expires, so it's open send then established. So we have a BGP peering session, BGP VPN V4 all peer. We have a peering session to SBR1. On SBR1, we can also display BGP VPN V4 all peer. We have a peering session that is up, and the number of messages that has been exchanged between the different routers. So we have our BGP, we have our MPLS, we have our IGP. Now the next step is we need to start creating the VRFs. Remember, I mentioned that with option A, we need to create VRFs for every customer. So we need to create VPN instances for different customers. So we have VRF1 and VRF2. For this case, we only have two customers that need to communicate, two groups that is. So we need to create VPN instances for these customers. So we are creating VRF1 and VRF2. VRF just for virtual routing and forwarding. Remember, VPN instances, we call them VRFs on Cisco. So we need to create the VPN instances, and with the VPN instances, we need to configure the route distinguishers and the route targets. And this one we are generally generating them from the loopback, from the AS number. So we have the route distinguisher that allows customers to use overlapping addressing spaces, and then we have the VPN targets or the route targets that control route import between different customers or different VRFs. So we will start by configuring P1. So on P1 will create the two VRFs, VRF1 and VRF2. So I can display current configuration. I just want to quit. Display current configuration, VPN instance. You can see that we have these two. We need the import and export. We are missing something on VRF2. Let's check. Oh, I missed this command for VRF2, so I can just reconfigure so that we have the import and export VRFs, the route targets configured properly on this router. So I've done the same. So I will display current configuration, VPN instance. You can see that we now have under the VPN IPv4 family, we have the route distinguisher and the route target for export and import of routes. So with this in place, we need to configure the other routers. We need to configure SBR1. Remember, I mentioned that the SBR will be keeping routing information for different VRFs. So we need to create these VRFs on the SBR also. So on SBR, but on P routers, we don't configure any VRFs because it will just be doing the swap operation for different labels. So I can display current configuration VPN instance to verify that our VRFs are well configured. And then we can configure the other routers. We have SBR1 and SBR2. So on P1, on P2, we'll configure these. We also need to run the same configuration on SBR2. So I log into SBR1 and run the configuration. So we have the VRF configured on P2. I will do the same. I'll configure the VRFs. So I can display current configuration VPN instance. I also missed one command here. I need it for the import. So I'll just run the two VRF so that it picks all the import and export. Remember, this is what is controlling the route exchange between different PEs. So we need to get it right. We need to configure the VRFs correctly. So I will also rerun it on PE. Those ones that are there will be, you can see that the VPN target is already configured. That is okay. So I can display current configuration VPN instance. We have the configurations now, are all okay. So we have configured the VPN instances on all the routers that require this configuration. The next stage is now to configure interface between SBR and bind VPNs. So we need to configure the two subinterfaces. We'll be using subinterfaces for this case. We need to configure one subinterface per VRF. So we have one for VRF1 and we bind there. This is the command IP binding VPN instance VRF1. We do the same IP binding VPN instance VRF2. So we'll run this on SBR1. We are just binding the interface facing the other SBR into the VRF. So we do the same on SBR2. So on SBR2, we are binding the VRFs. We have two sub-interfaces. That is okay, we have done that. And now the next stage is to configure BGP MPLS VPN option A. So I have mentioned that for option A, it's just VRF to VRF peering. So that's why you can see that on this SBR1, we are creating a BGP peering session for VRF1, and then we are creating another for VRF2. So it's just back to back. We are configuring BGP peering session between these two routers under the different VRF that we have configured on our routers. So we need to configure the peering session on SBR1. So on SBR1, we'll do the configurations. Quit, display these again. So we have the peering session for option A, the VRF to VRF peering. And then this is for SBR2. For SBR2, we need to do the same. So I will copy this and we have to verify that our peering session is up between these SBR for the different VRF. So I can display BGP VPN v4 all peer. It's still idle. We give it some time to be established. So normally it takes around 30 seconds. So we'll give it some time to be established. We are now 30. Yeah, you can see that it's established after about 30 seconds. So we have peering sessions on SBR1. We can also verify on SBR2. Display BGP VPN v4 all peering sessions. We have 2 peering sessions for VRF1 and VRF2. So once we have done this configuration, we now need to configure the customer facing interfaces on PEs. So we have a connection on P1 and P2 in the different autonomous systems. So we configure the interface and we bind the VPN instance before we configure the IP address. Remember, if you do it the other way, you will have to reconfigure the IP address. So normally we bind the VPN instance and then we configure the IP address. So on P1, I need to configure the 2 customer facing interfaces, and remember the VRF are already in place. I'll go to the next stage. The next stage we are configuring P2. So P2 also has 2 customer facing interfaces. So we'll configure the interface and then bind the VRFs and assign IP addresses as per the planned IP addresses. So you can see we have C4 and C2. So on P2, I'll quit and then configure the 2 interfaces. So now if we display IP interface brief, we can see that we have these interface assigned IP addresses and they are up. So once we have configured the IP address, we now need to configure BGP peering sessions between PEs and CEs. So for the PEs, remember we are configuring the peering session within the VRF. So we need to configure P1 under the VRF1 to customer 1 and VRF2 to customer 3. So I'll do that on P1. So I've configured P1. If I display BGP VPN v4 all peering, you see that we have 2 sessions that are in idle, one in S300, another one in S65500. So the next stage is to configure P2. So for P2, can paste, no, we need to be under the BGP. We are missing one command. So we need BGP 100 and then paste. Can verify display BGP VPN v4 all peerings. So we have 2 sessions that are down in idle state. We have 65000 and then we have 400, the ASS for the customer nodes. So the next step is now to configure the CEs. For the CE configuration, we are just configuring the customer name, that is the device name, and then we configure the interface IPs and configure the BGP peering session. So for the BGP peering session, remember we are using the loopback IP to simulate customer device. So we are configuring loopback IP 11.1.1 and then we are advertising this network into BGP. So on C1, these are the configuration that we need to configure. So I'll start with C1. I will undo terminal monitor and system and run the commands. So we have configured C1, C2. C2 is the same. We are configuring the customer name as customer 2 and then we are doing interface configuration and then interface IPs. So this is customer 2, and do terminal monitor again. System view, then paste. So we have configured the second customer. We need to configure the third customer. So we have customer 3. These are the configuration, BGP peering, the interface IPs. Can configure the router IDs also. So we have customer 3 here. I will undo terminal monitor. Then we can run the configs for this customer. And lastly, we need to configure customer 4. So for customer 4, this is customer 4. I will undo terminal monitor and then run the configuration. So at this stage, we have completed all the configuration that we need. We now need to verify that our BGP peering sessions are up on PEs. So on PEs, I can display BGP, VPN, V4, all peerings. You can see that we have 2 peering sessions to the CE, and we have another peering session to the ASBR. So on PE2, we can do the same, display BGP, VPN, V4 all peer. So we have 2 peering sessions to the customer. Then we can display the IP routing table, display IP routing table, VPN instance, VRF1. So we have an IP coming in from the customer. We also have an IP coming in from another customer. This is from customer 1, this is from customer 2. We can do the same for VRF2. Remember, the aim of using the VRF is to be able to separate these routing tables into different routing instances. So you will not find the routes for VRF2 in VRF1. So in VRF2, you can see that we are also getting the loopback IPs from C3 and C4. But if we display the global routing table, if I display the IP routing table, we don't have these VRF routes in our global routing table. They have been separated into their own VRF routing tables. So on P2, P1, I can do the same. I can display IP routing table, VPN instance, VRF1. You see that we have the routes coming in. And then we can also do for VRF2. We also have the routes coming in for VRF2. We can display IP routing table. For the global, we don't have any VRF routes linked to the global routing table. On CEs, we can display BGP peer. We have a BGP peering session to the PE. On CE2, we can do the same, display BGP peer. We have a routing peering session established between CE2 and PE2. So with this setup, we have already finished setting up our network, and we can test connectivity between the routers. So remember, the objective was to ensure that C1 can communicate with C2. So C1, when we configure this BGP, we advertise network 1.1.1.1. So if we were to ping, and if I display IP routing table, you can see that we have 8.8.8.8. We have learned the network advertised by C2. But if I just ping directly 8.8.8.8, the ping will not go through. One thing that we need to do is we need to source the IP that we have advertised to. Remember, when we ping directly, it's taking the source at the interface, the directly connected interface. So we need to use the loopback at the source. So I can ping -A this one will be 1.1.1.1 and I ping 8.8.8.8. So we are able to communicate from C1 to C2. Then for C4 it's the same. We can display BGP peer. We have a peering session. We can display IP routing table. We have learned an IP address from a C4. So we can also ping. Remember this is 999. We are pinging 10.10.10. So we are able to communicate between the Cs. And then if we try to ping, for example, from C3 to C2, we should not be able to ping. So we can ping 8.8.8. We are not able to ping even if we source. Let me see, 8.8.8. We are not able to ping between customers who are or who belongs in different VRFs. So this is it for our option A. Remember, I've mentioned that option A has one limitation, and the main limitation is that the ASBRs have to keep all the customer routes. They have to process all the routes, and then it's not scalable. It's not scalable enough. If you have many VRFs, the configuration workload is too huge, and then you need to have many sub-interface or physical interface between the SBR and between the SBRs, that is. So yes, it's very simple to configure, it's very simple to troubleshoot, but once your network has grown and you have many customers, you have many autonomous systems having to communicate with each other, it's not scalable enough. So that's why many times we go with option B and option C that are more scalable compared to option A. So this is it for this lab, and remember we have demonstrated different concepts in this lab. First, we have configured different protocols, OSPF, ISIS in different autonomous systems, and then we have implemented BGP, different BGP peering sessions between different nodes, between CEs and PEs, between PEs and SBR, and also between the SBR. That is for our option A, the VRF to VRF peering session. We have also demonstrated how to configure MPLS and MPLS LDP, just so that we have labels. So in our next episode, we'll be demonstrating how the traffic is routed in this option A, how the labels are exchanged. So we have mentioned that option A, we are using IPv4 to IPv4. So when we do the demonstration of us doing packet captures on this network, we should be able to observe that we don't have labels exchanged between SBR1 and SBR2. And then we can build on that and demonstrate option B and option C, that we will have labels between the different nodes. So guys, thank you for watching again, and please, you can reach out if you have any problem implementing this lab. You can reach out on LinkedIn and request for the files. And just remember to subscribe to our channel and stay tuned for more upcoming videos. Thank you.